we're really excited to see you guys today. My name is Robin. I've coached drones and robots for 9 or 10 years now across several different platforms, and I have a high schooler who's on the SPAM team right now. So that's who I am.
Hi guys, so my name is Cora and I am a high school student at Martin County High School. I am one of the vice presidents for FRC Team 180 SPAM. And I'm really excited to see what you have to show us today. So whenever you're ready to give your presentation, just let me know. Yeah, I think you could just do this up. Yeah.
Do you want us to move this table all the way? We can move this completely. Yeah, it actually went right here.
I'm gonna put it back here. So.
Alright, you guys ready? Yep. Okay.
Alright, Adrian, here's the GPR.
Thank you. Alright, let me just turn this on. Just turn that.
Thank you.
It's been a long day.
Yeah, we've been searching for hours and we still haven't found anything.
Yeah. Tell me if you get any readings.
Alright. Beep, 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 beep.
Guys,
Guys,
we found something.
quick, we found something.
Really?
Jin. Wait, I think that's bronze.
It's bronze?
Oh, it is. It might be a
Yeah,
bronze
wait,
statue, guys.
Guys, careful. Let's listen. Careful.
Guys, I think I have bronze disease.
Oh
Do you have a solution for this?
Wait, I have an idea. Let's use our bronze preservation chamber.
You're
Oh,
right.
yeah.
First, let's introduce ourselves.
Hello, my name's Excavator Jaden.
Expert brusher Max.
Explorer Leo.
I am GPR controller Yash.
GPR man Adrian.
And I'm Bronze Statue Connor.
And together, we are Fusion Force!
So first, let's introduce our problem here. Bronze disease. Bronze disease is a corrosive process that, when applied to like a bronze artifact, it corrodes the artifact and turns into like this greenish hue, like this mask right here, or like this image right here. This prevents us from further study of the artifact, and it doesn't allow us to look into the past of human civilization. But fortunately, we do have a solution for this.
The solution was proposed was to make a model of the gas chamber so that nitrogen passes through the tube, and then it replaces the oxygen inside the chamber which helps to preserve the artifact.
So here, we have a scale model and a diagram of our solution in which we have two sets of valves. One to allow oxygen to flow out and one to pump nitrogen in. We also have additional ventilation valves at the top and a flow meter on the inside to regulate the flow, along with PRV valves on the side to control the flow of the nitrogen. And this solution works because bronze disease needs oxygen to spread. If we make sure that the oxygen levels in the box are under 5% by displacing oxygen with nitrogen, we can prevent bronze disease from spreading and keep the corrosion away from our artifact.
Just to elaborate on Yash's and Leo's points, I wanted to expand upon what bronze disease actually is. It's a series of chemical reactions, right? I'm focusing on the third chemical equation right here. It requires cuprous chloride, water, which is H2O, and then oxygen to create hydrochloric acid and more cuprous chloride. So basically what we're doing is removing oxygen from the equation and replacing it with nitrogen. This essentially stops any progress of the chemical reaction from occurring, and as Jaden will talk about, we're going to try to also remove some water as well.
Okay, adding on to what Max said, in order to remove the water, we have to add a dehumidifier to the model to remove any excess moisture from the artifact. We could also add a thermometer, which ensures that the temperature is consistent while the artifact's being transported from the dig site to the lab.
So the reason we chose this problem is that millions of bronze artifacts, like Connor here, suffer from the same problem, and we thought that would be pretty useful in the archaeological community.
So we originally also had some other points, problems, like underwater archaeology and also a remote control GPR. But we ended up settling with Bronze disease after consulting with some people, and which Adrian will talk about.
Yeah.
And what's it called? We in the end we also we just decided Bronze disease, like it just stuck with us.
So, we would like to thank Mr. Manuel Kuroda, who's we reached out to through the Skype a Scientist program that was provided to us. And also we would like to thank Ms. Steinmetz from Bachman School of the Arts, who helped us reiterate our design for this and decide how many valves and other flows that we could incorporate. Thank you so much.
Thank you.
Thank you.
Thank you.
Thank you. All right, so now we're gonna go through some questions, okay? Let me see. Let me find a good one here. I was busy taking notes, which is a good thing, so I need to find a good question for you. How did your team divide the work for your innovation project?
So our team, right? It's there's 6 of us. So it's like an even number. We can like split the team up into like different groups. Like in the beginning we had like so in like the beginning we had like 2 people on like research, like developing like prototypes, and like other people like researching on the artifact, like how like you see how like Max had like explained these like chemical formulas here. Yeah, we like 2 people also researched on that, and like the other 2 were like contacting other people, and that's how we like divided the work.
So we also made sure everyone got an equal share of the project so that everyone could get like a taste like of what it's like being in each element of the project.
And if there were more than one idea, how did you guys decide how to move forward?
So we chose which idea to move forward with through how effective our solution would be and how useful it would be to archaeologists. For example, we had a remote controlled GPR idea, but we found that idea wasn't as useful as our bronze preservation box. So that's why we moved forward with this one.
Also, we made sure that every idea is heard because by understanding every idea, we can also use the parts of the idea to incorporate a better solution, as we are Fusion Force 2. So we combine the ideas together to make a greater project.
Okay.
We add, so our old ideas we don't just scrap them. Like for example, like the GPR idea, we just added onto it our skit as Yash and Adrian used like to find Connor.
Okay. What makes your idea different from other solutions you discovered?
Our solution is a more inexpensive way than others, and it shows the process the same way.
I have a question about your model. What are those valves at the top? You explained the ones on the sides, but what are those structures at the top for?
So we have 3 additional valves for further ventilation, either if there's a large amount of oxygen or a low amount of nitrogen. So you can choose which valves to use to pump in or out.
Okay.
And when you had your discussions with your experts, did they help inform the design of your solution, or how did they give you feedback?
So, Mr. Manuel Corrado, he is an archaeologist, and he gave us feedback on the pathway we wanted to do. Because at first we were like thinking of using underwater archaeology as our element, as we're in Florida. But we moved on to a more path that we were more passionate about, we feel. And Miss Steinmetz over here, she helped us like iterate our design because we weren't sure if we should incorporate 2 valves or 3 because having 3 valves, she told us that it can help with the efficiency of the distribution.
Okay. What has been your team's favorite part of working on your project this season, and why?
I think our team's favorite part is learning how to cooperate together and learning teamwork, basically. I think expanding upon each other's ideas and incorporating them into our solution has really helped us grow, and then I think also just coming up with our skit and other things like that have been really fun.
And what are you most proud of?
Anybody else want to answer that question?
Sure.
Yeah.
I'm probably most proud of how we can like keep like everything like on track while also having fun while like doing our project here.
I have another question about your solution. So, artifacts can come in all shapes and sizes. Would your solution come in a one size, or would you make it at different sizes for different things, or would you make like a really big one so that it can fit all of it?
I think we could definitely make customized sizes for larger artifacts. Maybe having one small, one medium, one large, just to make sure that we can ensure that all artifacts are treated correctly.
Alright, well, very good. I think we're ready to go on to the robotics portion if you guys are ready.